Hello, welcome. This is a video. You knew that. That was kind of depressing. So, this is a video about electric fields. My bad. All around. Okay. So there's a lot of different parts of electric fields that we're going to go over today. There are a lot. Let's just go with that. So, first thing we gotta talk about is action at a distance. It's pretty much exactly what it says. It's action at a distance. So an actional distance is happening right now. So it's like gravity. It's like this is the sun. And this is my tip of my finger. This part is like the Earth, and it's like rotating. Wow, that was embarrassing. Rotating because of gravity, but there's like nothing touching it. It's a distance, so it's action at a distance. Yeah. Another way to say it is this is a cookie, right? It's distant from my nose. However, I can still smell it, so it's action at a distance. So, yes, that was exciting. I like cookies. No, we didn't. Okay. So, next, electric field intensity. So the strength of an electric field is a vector quantity because it has both a strength and a direction. So it's a vector. The electric field strength, the equation for it is force, so the force of the object, F. Whatever. F to force over charge, so the charge of the object, which is C. It's like the whole thing's backwards, so it's really hard to make letters. So, there are two charges that have to do with an electric field intensity, which are the source charge and the test charge. The source charge is the charge that is from the object, the charge of the electric field itself. The test charge is the charge that is used to test the charge of the electric field. It's like you take your field and you throw something at it to see how much velocity, something like that. So, yeah. Next, this brings us to electric field lines. So the electric field line is the line that a particle would accelerate if it was in the field. So it's like you got your thing and it's got a field, right? So if I threw an object at it and it bounced off that way, there's a electric field line going that way, right? So there's like a bunch of lines going off the object. That's my head, and it's like. Now the less objects, the less vectors, the less strength, more lines, more strength. So if you want to have a strong object, you gotta have a lot of lines. So normal positive and negative would look like this. The negative go into the object because it's negative. The positive go away from the object because it is positive. And that is very good reason. So, when these lines, okay, so say we got a positive thing here, a negative thing here, then there's like the lines, and they like intersect and things, right? So let's go back to our cookie. So this is our cookie. It's positive because it's a cookie. Cookies are good. Good things are positive. So the cookie is positive. Anyway, so now we have our second cookie, which is also positive because it's another cookie. So they repel each other because they're the same. They're fighting over being the best cookie. They gotta be a better cookie, so they repel each other. Although both are very good cookies. Alright, and then if we have a cracker instead of a cookie, it's like this cracker's very shiny. Let's turn it over. It's still shiny. We have shiny crackers in this video because shiny crackers mean they're great. Okay, anyway, so the cracker is like, there's a cracker, and then there's the cookie. They don't fight because this is a cookie and this is a cracker. This isn't trying to be a better cookie than this cookie. This isn't trying to be a better cracker than this cracker. So they kind of like, they merge together and they form one awesome cookie cracker of awesomeness. Oh, my bad. Okay, so positive, really like this. So you see the lines here are repelling each other, making sure they don't touch. However, if it was like a cookie and a cracker, or it's a negative and positive, they like intersect and make a cookie cracker of awesomeness. You should, yeah. Just in case you didn't see it. That cookie's really good. What's next? Oh yeah, lightning. So y'all have all seen lightning, right? Like a boom, thunder, crack, in the sky, right? Well, this is because of electricity. Oh no! Oh my gosh. Okay. Yeah. So, what happens in the cloud right before lightning is the charges separate. So it's like the positive go to the top. So there's like a plus there. And the negative go down to the bottom. This happens because inside of the cloud there's like a whirling motion that creates friction, and then it's like positive end up at the top, negative end up at the bottom. Sorry. So lightning happens is when like the electrons at the bottom get attracted to either the protons at the very top of it, and them at the ground, which is why they go like ground, things like that. So yeah, that makes lightning, and they go very, very fast, which is why it's like what was I gonna say? Which is why it's it creates a lot of air resistance and stuff, so it heats up very, very quickly. So it like that's why it turns all white and stuff and colorful and beautiful because it's amazing. Yeah. So yeah. So there's a bunch of different ways to like protect your house from lightning, which is like a lightning rod. So lightning rod protects the building because of the lightning dissipation theory. According to the theory, the use of a lightning rod protects the building because it does. So it's saying that it's taking the charge and it's hitting this metal rod, which is the top, so it's the first thing it'll hit. So it's closest with its protons, it's closest to the electrons, and then it takes that and grounds it to the ground. That was a weird sentence. It grounds to the ground instead of grounding to the sky, because that doesn't make any sense at all. Anyway, so it grounds it right to the ground because that is very important. Whereas normally if it just hit your house, it would be like sudden discharge of lots of energy, boom, fire, lightning, explosions, fun times. And then your power gonna go out. Hits like a lightning rod's help because if it's like it hits the power cable to your thing, because it hit the normal thing of your house that connects to all the electricity, then it you can short circuit it or like have too much electrons go through it and like stop everything, break everything, and now you don't have power. Fun, because nobody needs power anymore. So let me just click a button. Okay, yeah, anyway. So that was all the things about electric fields. To go over one more time, action at a distance is action at a distance. Alright? What was the electric field intensity is the force of the electric field over the charge, right? It is how intense the field is. That's kind of self-explanatory too. The field lines look exactly like this. They're beautiful, and they say the direction an object would go if you like threw something at it. You're just like, and it's just like bah, and then it's like beautiful, and you're like, oh my god. And then anyway, so yeah, and then lightning is when negative charges are at the bottom of the cloud, positive at the top, and they get attracted and they make a zigzaggy thing, and it's really cool and everybody likes it. So yeah, this is the end of our video. Goodbye. Wrong mouse. Hey, I'm here because you just watched my video, and it was cool, and you know what it was. So, I've got one thing to say to you. Have a nice day.